Hello guys and welcome to the channel. Today we're going to continue about the continuity in mathematics, and that is part 2. I made 3 exercises for this topic from the simple to the hardest one. We have a theory here that is from the previous video in order to apply those 3-step continuity tests in our exercises. Okay, let's begin with the exercise 1. We have the function of x that is equal to x squared minus 14x plus 45 over x minus 9 for x greater than 9, and the square root of x plus 1 for x less or equal to 9. Now the question is this function continuous at x equals 9? Well, let's see the 3-step continuity test. Well, the first step is the f of 9 is equal to 4, and that is defined. For the second step, we will see the left and the right limit. So when the limit of x approaches 9 from the left of the square root of x plus 1 is equal to 4, and the limit when x approaches 9 from the right of x squared minus 14x plus 45 over x minus 9. That is equal to the limit when x approaches 9 from the right of x minus 9 times x minus 5. So we have factored this numerator here, and x minus 9 cancels out, so we end up with a limit when x approaches 9 from the right of x minus 5, and that is equal to 4. So the limit does exist because the two analytical limits are equal to each other. And the third step is that the limit when x approaches 9 of f of x must be equal to f of 9. So that is correct, and that is equal to 4. So the 3 steps are fulfilled, so the function is continuous at x equals 9. Okay, move on to the exercise 2. We have the function of x that is equal to e to the 3x minus e to the 4x over 12x for x greater than 0, and x minus 1 for x less or equal to 0. Now the question is this function continuous at x equals 0? Well, let's see the 3-step continuity test again. For f of 0 is equal to minus 1, so that is defined. And from the second for the second step, we have to see the left and the right limit again. The limit when x approaches 0 from the left of x minus 1 is equal to minus 1. Now the limit when x approaches 0 from the right of e to the 3x minus e to the 4x over 12x. From the important limits, we know that the limit when x approaches 0 of e to the x minus 1 over x is equal to 1. So we have e to the power of 3x and e to the power of the 4x, and we need to transform them into the form of e to the x minus 1 over x. So we can add and subtract 1 in the numerator, and we have the e to the 3x minus 1 plus 1 minus e to the 4x. For 1 minus e to the 4x, we should factor out the minus 1, and we'll have the minus times e to the 4x minus 1. So for this here, e to 3x minus 1, we need to multiply and divide by 3x, and for e to the 4x minus 1, we need to multiply and divide by 4x. So here we have the limit when x approaches 0 from the right of e to the 3x minus 1 over 3x, that is equal to 1, and of course that is equal to 1, and we'll end up with a limit when x approaches 0 from the right of 3x minus 4x over 12x. X cancels out, and we'll end up with this limit that is equal to minus 1 over 12. We see that our second step does not exist because the analytical limits are not equal to each other. After that, we will see that this point, this example x equals 0, is called the breakpoint, but that is for next video. Okay, move on to the last exercise, that is exercise 3. We have the function of x that is equal to the cosine of x over the cube root of 1 minus the sine of x, and that is all squared, for x greater than pi over 2, and is x minus pi over 2 for x less or equal to pi over 2. Okay, now the question is this function continuous at x equal pi over 2? Well, again, we'll see the three-step continuity test. The first step is that f of pi over 2 must be defined, and that is equal to 0. So this is defined. The second is to see the left and right limit. We have the limit when x approaches pi over 2 from the left of x minus pi over 2, that is equal to 0. And the next limit is that the limit when x approaches pi over 2 from the right of the cosine of x over the cube root of 1 minus sine x all the square. Here we need to do the substitution with t, right? T is equal to pi over 2 minus x, so the x is equal to pi over 2 minus t. If you put the value of x here of pi over 2, then t is equal to 0. And we have that the limit when t approaches 0 of sine of pi over 2 minus x. So the cosine term, I write it in the sine of pi over 2 minus x. And the cube root of 1 minus the cosine of pi over 2 minus x. We know that the sine of pi over 2 minus x will make this substitution here, and that is equal to sine of t. But from the important limits, we know that the limit when t approaches 0 of sine of t over t, that is equal to 1, so we need to transform this into this form right there, sine of t over t times t. And from the cosine, we know that 1 minus the cosine of t over t squared when in the limit when t approaches 0 is equal to 1 over 2. And we'll need to transform this. And that is, here is a transformation. 1 over cosine of t over t squared times t squared. That goes to 1 over 2, and that goes to 1. So we end up with a limit when t approaches 0 of 1 over the cube root of 1 over 4 times the cube root of t. If you put the value of t is equal to 0 here, we'll end up with the 1 over 0, and that is equal to infinity. So the two uniliteral limits are not equal to each other, so the second step does not fulfilled. So the limit does not exist.